Hey guys, welcome to the Team Teach 2 presentation. I'm Joni Overly.
I'm Gabby Guest.
I'm Calie Plummer.
And I'm Amanda Pennington.
And we are going to let Calie take it away.
So before we get into the actual lesson and presentation, I figured we would go over some of the angles to give a little background knowledge in case you're not familiar with them. So a supplementary angle is when two angles or more add together to equal 180 degrees. A complementary angle is when two or more angles all add together to equal 90 degrees or a right angle. Similar angles are when you have two triangles of similar sizes, but their angles are the same degrees, and you know that they're going to be the same degrees because the triangles are similar in size with the same degrees. Corresponding angles are when two parallel lines are cut by a transversal line, and so the resulting corresponding angles are congruent. So like angles 1 and 5 and 2 and 6, 3 and 7, and 4 and 8. Vertical angles are when you have two non-adjacent angles formed by two intersecting lines. So in this case, the vertical angles would be 1 and 3 and 2 and 4.
Okay, so for number one, Calie, how are supplementary angles different from complementary angles?
Supplementary angles are angles that add up to be 180 degrees. And so some examples on this particular graph would be angles 7 and 8, 9 and 10, 11 and 12, and then angle 6 and angle 61. And complementary angles are angles that add up to be 90 degrees or a right angle. And on this graph, there aren't any.
Okay, good job.
Thank you.
All right. Gabby, what does a supplementary angle mean, and how do we know an angle is supplementary? And give an example.
So a supplementary angle is two angles that add up to be 180 degrees. So you could just pick any numbers on this line graph. So 119 and 61 add up to 180 degrees. So that's just a kind of overview of what it could be.
Alrighty. Well, thank you so much.
Amanda, are there any supplementary angles in this graph?
Yes, there are. What we're going to do is we're going to take the first top portion of angles 1, 2, and 3, and we're going to look at that on a different slide. So here's our line, and here's our angles for 1, 2, and 3. We know the angles with the 56 degree, 63, and 61 all have to add up to 180 to be supplementary. So yes, there are supplementary angles in the graph.
Great job.
Thank you.
Joni, in problem 5 from our homework assignment, can you name the vertical angles?
Okay, so first of all, each of the pairs of opposite angles will be intersecting by two lines. So a couple of examples are like our angle 2 and 63 that are across from each other, and 4 and 3. As you can see, there's going to be several of them in this.
Thank you.
Okay, so Gabby, is there a complementary angle in this shape, and what are their requirements?
So no, there is not a complementary angle because there are not any two angles on here that can add up to be 90 degrees. And yeah.
Thank you.
Amanda, can we identify any supplementary angles in this triangle?
Yes, we can. We can, because supplementary angles we know have to add up to 180. And so when we look at all the degrees that are added, we know, for example, angle 2 and 3, that angle 2 is 100 degrees and angle 3 is 80 degrees. So since it's a supplementary line, we know that that's going to be an angle of 180. And there's many more in this that are 7 and 8 also a pair. And then if we look at angle 4, 5, and 6, we know all those have to add up together to get 180 as well.
Well, thank you.
You're welcome. Are there any different methods of finding the degree for angle 6?
There are. So angle 6 in this triangle is one angle of a whole triangle, meaning that angles 6, 8, and angle B will add up to be 180 degrees. And so you would just substitute, you can follow the formula on the side, the degrees for angle 8 and angle B, subtract those from 180 and you would get 74, which is the degree of angle 6. Or it can be found using supplementary angles. So that means that angle 4, 5, and 6 will all add together to equal 180. So if you have the degrees of angle 4 and angle 5, you can use those to find the degree of angle 6.
Oh, okay. Thank you. In our homework problem 8, what can you tell us about angles 3 and 8?
Okay, so when two lines are parallel, the corresponding angles are equal. So angles 3 and 8 both are the same at 80 degrees. And they'll have both the same.
Alrighty, thank you so much.
Gabby, using both questions 1 and 2, can you point out the measurements that are congruent and explain what that word means?
Yes, so congruent is just pretty simple. Congruent means that something is the same. So you can look on both graphs. And over here, on the first graph, you can have angle 61. Corresponding to it, you have 61 degrees again. So that would be congruent. And on to the second one. So for angle 1, it's 80 degrees. And for angle 3, it's also 80 degrees. So that's just what congruent means.
Great, thanks so much.
All right, Amanda. How can you find the measures of a concave polygon?
Okay, so one of the things you can do, we have the formula for steps 1, 2, and 3 that take you through it. So we know that our formula in step 1 is saying that n minus 2 times 180 will give us our answer. We know n is going to be our number of sides that we have for our concave polygon, which we know is 8. When we plug in the 8 for n and solve, we get 1080 degrees. We are going to hold on to that number and move on to step 2. Next, we're going to add up all the 3y, 7y, 12y's all together and see how many we have. And that brings us to 54y. Now, since we know 54y is going to be equal to the first degree that we got in step 1, which is 1080 degrees, we're going to solve that equation for y. And in doing so, we have the solution result of y equals 20. And when we plug that y in for 7y, 3y, and 12y, we'll get our answers of what each one will mean.
Okay, great. Thank you.
You're welcome.
Callie, what should be the first angle that you find?
So when you look at this whole triangle, you'll notice that in the large triangle, 2 of the 3 angles are found. And so when you have 3 angles of a triangle, they equal 180. So angle 1 would be where you would start, and you would add the degrees of angle C and angle B, and subtract those from 180, and you get the degree of angle 1.
Thank you.
Does the same method work on other shapes, Gabby? For instance, a square?
Yes, so this same method can almost work on any shape. So let's say you have a shape, which would be a square, and you know that squares always have the same angle. So let's say it's a 4 by 4 square. So it's 4y by 4y by 4y by 4y. So all you have to do is just set it in the same equation that was on the last slide, and the equation is x minus 2 times 180. So x is the amount of sides, and squares have 4 sides. So all you do is take 4 minus 2, and you get 2. You'd multiply that by 180, which would be 360, and then divide by 180, and then you'd get 2.
Oh, that's fascinating. Thank you.
Joni, is the formula of the measures of the interior angles of the convex ingon?
So the formula for to find the measure of the interior angles will be your n minus 2 times 180 degrees.
Well, thank you.
All right, Callie. In homework number 20, how do you find the sum of all the interior angles?
So in order to use the formula to find the sum of the interior angles, you would have to find what n represents. And n represents the number of sides of the polygon of the angles that you're trying to find. So in this case, n would be 8 because it's an 8-sided polygon. And so you would substitute n for n, and you would get 1,080 degrees. And then if you wanted to take it a step further, you would add up all of your interior angle representations, so 3y, 7y, 7y, and so on. And all of those added together would equal 1,080, which is 54y. Then you would just divide, which y equals 20.
Okay, good job.
Amanda, how can you find the angle measurements without any number values?
Well, that's a good question. So at the beginning, I looked at this and I'm like, how can I find any values for an angle without any numbers at all on this concave polygon? And so what I noticed is that we can use the formula for the interior angles, exterior angles, and central angles. And all we have to do is know the number of sides. So we know when we count that the number of sides is 9. So we plug that into the formulas. And so for the first one, the interior angles, when we plug that in, that gives us 140. And so when we look at exterior and central angles, we're going to use the same formula. So we know 360 divided by n, or 360 divided by 9, will give us 40 degrees for both exterior and central angles.
Thank you.
Welcome.
Okay, so next we'll have Gabby explain how you set up the equation to find your values.
So this is very similar to what Amanda was saying. So all you have to do is just set up that same formula. You just count the number of sides, which in the middle I put that there were 9 sides in the interior. All you have to do is put it in the formula. So 9 minus 2, and you would get 7, and then multiply by 180 and divide by 9, and then you get 140, and then you would take 360 divided by n, which is 9, and then you'd get 40.
Okay, good job.
Joni, in the polygon, how do we find what n is to measure our interior angles is n minus 2 times 180 divided by n?
Okay, well, it's still about the same as you ladies were talking about. Basically, we just, to determine what our n is going to be, our n is going to represent the number of sides. So in this one, we're just going to count our sides. And in this particular problem, it has 9 sides. So 9 is going to be what our n is in our equation. So we'll just use our 9 in place of that and calculate our answer. And that's it.
Amanda, how can you put a tetrahedron inside a cube without touching any of the cube planes?
So that was something I also had a question about. How are we going to do that? Well, we know that that means any of the tetrahedron cannot touch any faces on top of a face of a cube. So that means any of the triangle faces can't touch a square face. So as you see in the graph, the green and blue lines are indicating the cube, and the yellow lines are showing the tetrahedron. And so we can see that, in fact, none of the faces are laying on top of a plane of the cube.
Great, thank you.
You're welcome.
Joni, we know that a tetrahedron is a three-dimensional shape. How many faces does it have, though?
So basically, that's just super easy. It will have 4 faces for a tetrahedron. And that's how we know.
Calie, why are the degrees of a central and exterior angles the same?
Well, pretty simple. It's because the formulas for the central and exterior angles are the same. And so when you're finding them for the same shape, your n is going to represent the same number. And so for this particular n-gon, the polygon, I'm sorry, 9 is in place of n, and so both of the degrees are going to equal 40.
Thank you so much for clarifying.
Okay, so Amanda, what is the easy way to know how many faces belong to each figure?
Okay, so one thing that I like to do is I like to know the root word or the first beginning of the word meaning. So what I found really fascinating was that I know that tetra will mean 4. So that means that a tetrahedron will have 4 triangle faces on it. And then I know octa, like an octagon or an octahedron, that's going to have 8 plane faces on it. So that means that our triangles have to have 8 triangular faces on it, as shown in this one right here with the red dots. We know that there's going to be 8 triangle faces on there because of the root word octa. And then isosahedron, we know that isosa is going to be 20. So we know that we need 20 triangular faces for this triangular shape. And so that is going to be how we know.
All right, thank you.
You're welcome.
Joni, in problem 40, how many faces, edges, and vertices does an octahedron have?
Okay, so like she just explained to us about that one, you start with your root word, and so it's that octa. So we know that it is going to have 8 faces, and then it will have 12 edges and 6 vertices.
Okay, thank you.
Gabby, go more into detail on each shape other than just stating the number of sides.
Okay, so let's start off with tetrahedron. So tetrahedrons are also known as a triangular pyramid, in just like simpler word, and it is the simplest of all ordinary convex. Next, let's do the isosahedron. So the isosahedron has 20 faces, 30 edges, and 12 vertices, and it is one of the 5 platonic solids. And last, with the octahedron, this is a platonic solid as well, and it is the dual polyhedron of a cube.
That's so fascinating. Thank you for sharing more on those.
No problem.
Okay, and Calie, what are the characteristics of the isosahedron?
So the isosahedron, like the other ladies were saying, is a polyhedron that has 20 faces. And so because it has 20 faces, it has 30 edges and 12 vertices. And meeting in every vertex are 5 equilateral triangles.
Okay, thank you so much.
Mhm.
So thank you guys for watching our Team Teach video. I hope you guys learned something from it, and I'll see you next time. I'm Gabriella Guest.
And I'm Joni Overly.
Calie Plummer.
And Amanda Pennington.